Firepower Threat Defense, Common Practice Guide, Walkthrough. So recently I've been asked to author a common practice guide for Cisco's Firepower Threat Defense. So I did that, and they've developed a nice looking click book that you can quickly navigate through. And now I've been asked to kind of do an audio walkthrough of it, including demos. So that's what we're going to do. So the book's made up of 3 parts, right? Part 1 is policy management. Part 2 is device management. And then part 3 is additional information and resources. So we're really going to focus on part 1 and part 2. Part 1, policy management, we're going to talk about access policies and some of the things that you might want to consider when leveraging access policies. Then we'll move into IPS policies. Again, there's a couple of things to consider. And then we'll move into, malware policies, SSL policies, identity policies, and then finally network analysis policy. So access policy, so rationalizing. So one of the biggest things you want to do is make sure that you rationalize those legacy firewall rules, right? Decommission rules that are no longer required. This ensures that access is not granted by accident to things that should not have access, and it further optimizes the rule set. Look to simplify the rule set using objects. So we're going to go through an example here where we're going to do, we're going to look at a couple of services and consolidate them. And it gives us an opportunity to add additional security services to it, like IPS and malware. So first thing we're going to do is that we're going to come in and we're going to edit the access control policy. We're going to define, we're going to add a rule, and then we're going to define the zones. So if you have, for example, a couple of web services in the DMZ area, and they all offer the same things, right? Maybe they offer FTP, HTTP, and HTTPS. Well, we can group these together and make a nice single consolidated rule, and then we can add inspection, whether that be advanced malware or IPS or a combination of both. So here we're going to do outside to inside, or the DMZ, for example. Again, I'm just showcasing this. And here we're going to pick web servers. So in this case, we're going to look at web servers, and there's 2 web servers that are part of this object group. And again, we can create our own. We can do this based on application if we wanted to. We can do it based on ports. And again, when you're building out rules, and I'll talk about this a little later, less is more. Just because you have a variety of attributes here available to you doesn't mean that you have to leverage every single one of them. All we want to do is make sure that we're capturing enough attributes to define the flow uniquely, right? So here we've got a couple of ports, right? So we'll grab FTP, for example, right? We can define our own port objects right from here if we wanted to. So let's grab FTP, and then the others could be HTTP, HTTPS. And again, the idea here is that the servers in the DMZ in this case all offer these 3 services. So we can consolidate here, right? We'll give it a name, and then obviously the action itself, whether that be allow or deny. And this is where we can add additional advanced inspection, like IPS or malware. Placement of the rule is critical, right? Make sure that it's placed where it's gonna actually match, right? And then we'll add that rule. You save the rule out, and then ultimately you have to push that rule out to the next gen firewall or firewalls, right? Because you can push to one or many devices at the same time. So now quick summary, we can look at outside to inside. We've got this web server object. That's a collection of web services, FTP, HTTP, HTTPS with IPS and logging enabled. Again, save that out, and then we can deploy. So pretty easy. All right, so the next example we'll go through is not all rules are equal, right? So when we look at rules themselves, not everything needs layer 7 inspection. Some require L3 or L4 inspection only. They're trusted flows. There could be finance applications, they could be backups, etc. So we want to optimize those flows and not have to push up to layer 7. So this is what we call a pre-filter policy. So in this case, again, I'm going to fast path. So this is to ensure that I'm actually meeting the requirements. So in most cases, 5 tuple, right? And then I'm going to pass the traffic on based on policy, but I'm not going to do additional inspection. So there's no application identification, right? There's no IPS or malware. So again, I pick the interface objects, right? So the zones themselves, maybe some network to define the flow itself. And I'm just showing that there's a variety of things here, right? Inside hosts, etc. These are objects that may have already been created. And I might be looking for something that I'm using for backup, whether that be FTP, a specific protocol, NFS, SMB, or whatever, right? And then what I'll do is add that, and then this traffic profile will only hit up to layers 3 and 4, right? We will not go into the advanced inspections. Again, the idea here is that I optimize the rule set and don't increase a performance penalty to do further inspection to flows that don't require it. And that's something that's unique, right? We're not actually sending the flow up to layer 7 to discover application and then trying to optimize it later. We are saying at this point in time, this is a trusted flow and there's no additional inspection required. Here we're going to log at end of connection. We'll talk a little bit about that later on. And we'll save this out and then we can go ahead and deploy. Now, before we actually deploy, that pre-filter policy has to be added to the access control policy. So let's go back and add that here. And now that policy is there, added to the access control policy. It'll now be used for the devices that are assigned to that device, or that policy, sorry. Connection logging is handy, but comes with an overhead, right? Both system and the number of entries logged. So security intelligence, IPS, malware events are already generating threat data and can alert without having to configure connection logging. So log what is appropriate, right? And optimize the logging. Do not log at beginning and end of connection. If you want additional data, such as traffic over the duration of the session, application details, etc., you should log at end of connection. And then longer term event storage should be sent to an external storage, such as a SIM or syslog, or using our advanced eStreamer capability, right? That provides additional capabilities when logging. So what we'll do is we'll go through an example of connection logging, and I'll also walk through some of the alerting as well. Okay, from access control policy, we'll go in and edit a rule. And while we're in here, you can see there's a variety of actions, right? Allow, trust, monitor, block, block with reset, interactive block, and interactive block with reset. So lots of different options. So you can log at beginning of connection or log at the end of connection, right? Again, typically block is going to be at the beginning because there is no end of connection. And with an allow policy, for example, it'll be log at end of connection. All right, so that was pretty easy. Real quick, I'm going to show you how to set up alerting. So you're already going to get logs for security intelligence, IPS events, malware events, etc. But you may want to generate alerts as well. And here what we can do is we can create alerts for things like syslog, email, SNMP, right? So you can define those objects and then send to them. And then you go in and select the impact flags that you want to generate in this case, right? So this is things where IPS is determined, the impact of that threat. Let's look at discovery events. So we can look at things like if a client is added to the network or new host. We can look at things like IOCs, for example, or things to do with a new operating system added to the environment. All of this is important for us to understand the network that we're providing. So you can generate alerts based on discovery, which is pretty cool. And then we can move into things like advanced malware. So again, very much the same, right? We defined whether we want a syslog, email, or SNMP, what those objects might be, and then we have retrospective events, and then malware events as well. That could be sent to one or many of these locations. And then intrusions, we could very quickly set up an alert that sends an email out as well, right? And again, you just define it here and then save it out, and you're good to go. All right, so let's talk about defining flows, right? So understanding the flows within the environment and the classification of the asset you are protecting is critical, right? Be sure to have strict controls in place with advanced inspection for critical hosts, right? So high value targets. When building advanced inspections, ensure you optimize the policy. So for example, malware policy for an HTTP repository in the DMZ, you want to grab the attributes that are relevant to that, right? So in this case, HTTP we'll use as the protocol. Maybe the direction is uploading, and at that point we want to run malware, right? Or we may want to block certain file types. So let's go through an example of that. So here we are under policies, malware policies. We're going to define a name here. And once we do that, we'll come in and add a rule. Now, I've really kept this to focus on the actual part within the document. So I'm not expanding too much beyond that. There might be a little tidbits here and there, but I've really tried to stay true to the document. So here we selected HTTP. The direction of transfer is going to be uploading. We're going to block certain file types. So again, we're very focused on HTTP here, as opposed to any application protocol. And then we're coming through and we're selecting what files we want to block. So maybe we want to block things like executables, right? And we don't want any additional inspection. So that's fine. That's for HTTP. And maybe now we want to do another rule for, HTTPS, right? Or FTP. Now, if you use HTTPS, I want to make sure it's clear. You have to have an SSL decrypt policy in place, right? In order to be able to see that traffic. Again, here, very much the same. We're going to go through and we're going to say we're going to block these file types because we don't want, executables going up to our FTP or HTTP repositories. There's no reason for it. So when you build out your rules here, the most restrictive applies. So in this case, the blocks are obviously just going to block that traffic with no additional inspection. But we may want some file types to go up, right? And in this case, maybe some document types, right? And in this case, again, HTTP upload, but now we're going to do block malware, and then we're going to add additional inspections like machine learning for executables, outside looking in sandboxing for dynamic analysis. We've got some capacity handling, so if the box can't send the file, we'll hold it until we can send it for sandboxing. We got local malware analysis, that's high fidelity signatures to do some quick or early scanning. And then we can reset the connection, right? So again, we take off the executable because it let us know that there was no executables there. You'd have to add that. And since we're blocking it, there's no reason to have executables go through the machine learning activity. So again, we're copying pretty much what we've just done for HTTP, right? And the dynamic analysis and local malware analysis capable files are just files that fall under those categories that allow for those types of behaviors. So dynamic analysis, again, is that outside looking in sandboxing capability. And local malware analysis are high fidelity signatures on box. And I went back and made sure the previous rule was the same. The warning on the side is just letting us know that there is going to be no inspection of executables, and that's fine because we're blocking them in this case. Now that we've done that, we have to go and go into the access control policy and apply that specific rule. So if we go back to our web service rule that we created originally at the beginning, now we can come back to inspection. We can go to file policy, and we can be very specific here with that policy with HTTP and FTP, for example. Right? And there's two things that we're doing there, right? We're blocking traffic and we're also looking for malware for the traffic that we allow. So blocking bad traffic, right? Leverage security intelligence to block known bad traffic helps with the overall risk to an organization, but also drops traffic without additional inspection. This is key. So when blocking bad traffic, what we want to do is build rules as granular as possible. Less is more, right? It isn't about defining every single attribute. It's only the attributes that are required. So now that we've got that established, let's go through an example and walk through this together. And this is pretty quick and easy stuff, right? All right, so let's go into access control policy. We're going to go to security intelligence feeds. And if everything is configured properly, you should be able to come in here and grab all of the security intelligence feeds for networks URLs, for example. And what we'll do is add them to blacklist. We could set this as a monitor policy if we chose to do so. But in our case, we're going to block, right? And again, we can set up some logging here as well. And then URLs, we're going to do this at the top level, right? We can do URLs very specifically within a policy, but in our case, we're going to say, you know what? We don't care if anybody's going to any of these blacklisted URLs or networks. We want to stop them in their tracks, right? Save this out. And again, we would push this and deploy it out to the assets that are assigned to this policy, and we'd be good to go. But from here, what I want to do is talk about the rules itself. So when you go in and define a rule, you pick your zones, your networks, you have VLAN tags, you have user identity, right? You can add Active Directory users as well. We have applications such as Facebook, for example, or whatever, right? We use a Open App ID, which allows for higher levels of efficacy when it comes to application identification. We have ports, right? We have URLs that you can go through and do filtering on as well. And then we've got secure group tags, and this is an integration with Active Directory, with Identity Services Engine. And you would not grab every one of these, right? You'd be very selective. And if you look at the rule set that I have here, I'm being very selective, right? I'm not selecting, every single attribute to define the flow. As we move along here, we want to know when we move into encryption, we want to make sure that we are doing this properly, right? So if you are going to decrypt TLS, be sure to that it aligns with your corporate policies and engage HR in the discussion to ensure that you're not violating policies. So, for example, you have a policy that allows users to use compute resources for personal work and related activities. So we have to ensure that the acceptable use policy outlines what traffic may be inspected and whether privacy is maintained for things such as finance and health, right? Also consider additional resources or technologies for things like encrypted malware running on the network. So we can use encrypted traffic analytics for such things like that, which allows us to do it without having to decrypt the payload itself. So as we go through here, let's go into an example, right? So we're going to create a very quick, and I'm not showing you how to build the certificates and doing all that stuff that we typically do in some of my other videos. This is, it's already ready to go, right? At this point in time, I'm just showing you the rule creation and some things to consider. So if we edit that out, now that we have the SSL policy, let's add a rule. And we can see the defaults do not decrypt. But this is why I think it's important to add a policy higher up that says do not decrypt. Partly to do with just in case someone makes changes to the environment, they're not actually overriding this policy. So we'll make sure that this is at the top. We'll pick the proper zones, maybe the networks, maybe very specific users, right? But in this case, we want it to be as vague as possible because we want everyone to fall under this. And the idea here would be it's going to be a do not decrypt policy, right? We're not going to decrypt regardless of any rule that gets set below this. This will always match. And the idea here is to match finance and health. So give it something descriptive in the name. And bank and finance is the same thing. So let's change that to health. Or I will shortly. So we'll grab the categories. I'll modify the name to be bank and health. And ultimately we'll save this out, set the appropriate logging as desired, and then you would save this out, and then we're going to go and add this to access policy. So let me just finish off here by fixing the name here. We've got the source, categories, we can just quickly go and add now. So there's the finance. And let's go down a little bit further here. Health. There we go. All right. So we've got the two categories of interest. We see the logging is set. We add this policy. In anything set below this rule, we don't have to worry about it, right? Because we've mitigated that based on the policy itself. All right. So we'll save this out. We'll go to access control policy. We'll edit the policy itself. And you can see here SSL policy. All we're going to do is drop that down. We'll assign it. And now that access policy and all the devices associated to that access policy will get this policy. And then ultimately we deploy. The other thing too is we want to leverage the online help, right, as much as possible. And that's going to show us more. So things like advanced settings, right, within access control policy, there's a lot of things here, right? And some of this you're not going to know. And maybe many of it you're not going to know. And that's okay, right? Some of it we've already started tweaking a little bit, but just leverage online help. It's there, it's available. And then your specific requirements that you may have, you can come in here and just get a little bit better understanding of what setting may apply to that specific use case. Right? And it's fairly comprehensive, and it pivots you right to the area of interest. So if you're on that guide, it's going to get you there. So now we've done a little bit of access control. Let's talk a bit about IPS. So testing policies. This is a big one, right? Make sure you test. So we do a lot to help you with this, but you can test policies where you can. So this can include configuring the device to be passive or inline tap, or inline with the drop when inline unchecked. And I'm going to show you a bit of that in a second here. But the idea is that because we understand your environment, we can tweak it by even being deployed in a passive deployment, right? Or kind of like an IDS type deployment, right? And the way we do that is a couple of things. First off, we can just span your traffic to the device and have an interface assigned to passive. And again, throw our IPS policy based on that specific zone, right? In this case, it's called the passive zone, and start building our policy and tweaking, right? To make sure that the behavior is the right behavior that we want. So that's option one. The other option might be that you do have an access control policy in place. It is in line. So essentially it can block. But what we'll do is we'll come into the IPS policy itself and just uncheck it. So drop when inline, we uncheck it. Yes, we're still inspecting, but now we're not dropping the traffic. So a quick way of testing policy before turning on intrusion prevention. So let's move to variable sets. So variable sets provide deeper accuracy in terms of detection and reduce the amount of noise. It's critical that you populate variable sets with information that reflects your environment, and you should also update your variable sets as your environment changes. So majority of the rules use the variable home net to specify protected network and a variable called external net to specify the unprotected or outside network. Also, specialized rules often use other predefined variables. For example, rules that detect exploits against web servers use HTTP_servers variable and HTTP_ports variable. Rules are more effective when variables are more accurately reflect your network environment. At a minimum, you should modify the default variables in the default set. By ensuring the variables such as HomeNet are correctly defined, your network and HTTP servers include all web servers on your network. Processing is optimized and all relevant systems are monitored for suspicious activity. So the better you get at modifying the variable sets to reflect your environment, the better your IPS is going to be. So let's look at this. This is actually pretty easy. So all you do is go into variable sets. We could just do the default variable set, but you could create different variable sets for different platforms as they're deployed in your organization, right? You might have hundreds of firewalls, for example. So we can come into HomeNet, and when we hit edit, what we'll see is these are objects that we've already defined as objects, right? Within the objects network container, right? So we define them, and now we can just add them over, and I've already done that here for HomeNet. So that's good. Now, if we go to things like DNS servers or HTTP servers or FTPs, etc., right? We can come in and we can add those assets here as well. So pretty easy, right? No big deal here. We save this out, and now we have this variable set. Now, we still have to assign it, right? If it's the default, well, it's already assigned. In this case, we did modify or create a new one, and we need to assign it. So again, we go to advanced. If we weren't sure what advanced stuff or the meaning of these things in advanced is, we go to online help, as we showed you earlier. Or we just quickly come in here because we know we want to change the default set. We edit this out, and we get a drop-down box, and now we can see that list that we just created. We select OK, and we can save. Okay, remember, until you save and deploy, many things don't work, right? They're there and ready to go. The next one we'll talk about is firepower recommendations. Now, this is key, right? Firepower recommendation uses data that we passively collected about the operating system, servers, and client applications within the environment, and then associate specific rules to protect these assets. So firepower recommendations helps automate tuning and should be considered part of operations. Whether it is performed manually or scheduled as new services are added to the environment. So as you add new, you might want to rerun this or schedule it. In order for NGIPS to be effective, tuning is key. And this is very important, right? Cisco Firepower makes tuning easier and relevant to your environment that you are protecting by leveraging the Firepower recommendation capability. Again, the key thing here is that you can't protect your environment effectively if you don't know what's in your environment, and Firepower empowers us to do that. So what we want to do here is we'll run through a quick example. This is going to be fairly quick. And we'll go into intrusions. We're going to edit the policy that's in place. Now, my environment's small, but this is still going to give you an idea of what you need to do. So the first thing, you can come in here and you can update recommendations, right? So you start with a default policy of some sort, and then you let it run, and then you can come in here and ask for recommendations. And we'll talk about some of the default policies that are available to you. And since I did that, we can see very quickly 149 rules are now changed to generate events. It shows me the number of rules, the number of hosts. I can very quickly pivot and see all the recommendations for drop and generate events, which is pretty easy. Here's a quick summary of that as well. Let's go back to Firepower recommendations and look at the advanced settings, right? So it gives me a good breakdown, and I can change this threshold behavior, right? To high, to low. I can add networks that I want to focus on examining. Again, I can view any specific rule that I want to. And the big thing here is, look, there's a tremendous amount of rules that are disabled because we don't see anything in the environment that reflects those rules. All right, so the next one would be X forwarding. So this is leveraging proxy, right? So if you have a proxy deployed, you will want to capture the client IP address to determine who is requesting the request, right? So if I go to a proxy and out to the internet, well, the proxy is what the Firepower sees, not the client IP address. So the idea here is that we're going to extract the client IP address out of the X forwarding capabilities of proxy. So you'll have to do this on the actual proxy. as well as on Firepower. Now, I'm going to show you on Firepower. There's a bunch of default stuff that's already done, but we go into policy intrusion, and then we go to network policy analysis. And we're going to create policy, network analysis policy. We're going to actually go in and edit or create, right? It doesn't really matter. Now, this should reflect your IPS policy. So if you've used balance, security, and connectivity for IPS, the base here should be the same. Now, you can see here HTTP configuration, right? We can edit that. And you can see there's a tremendous amount of configuration items in here, right? What we're looking for is the extract original client IP address is checked, and the X forwarding header priority, so X forward 4 and true client IP is selected. We commit changes, right? You got to remember we have to deploy as well, right? Always look to deploy. There's some settings that are Firepower management focused, the platform, but a lot of them do go out to the sensor itself. All right, so that's good. But the other thing that we have to do is we have to come in and turn on a couple of signatures that are related to that configuration item. And that includes GID 119 and with SID 30, 23, and 29. So what we'll want to do is either we want to generate events here. So when that comes in, we actually get the true client IP address based on those signatures when they fire. We want to commit the changes here, hit OK. And again, if this is already assigned to an access control policy, great. Hit the deploy button. You're good to go. If it's not, then we need to go back and do that. So fine-tuning rules. So do not enable all IPS rules, as this will degrade performance and will add a lot of noise, right? You'll get a tremendous amount of noise, and there's not a whole lot of value of doing that. That's old school, and it's going to kill the box. So tune the policy and leverage Firepower recommendations that we just talked about. Most customers start with balance, security, and connectivity policy and tune from there. When we enable preprocessors, you need to ensure that the IPS policies get the alerts and actions as well. So there might be IPS policies associated to a specific preprocessor configuration. We highlighted that just a minute ago with X forwarding. So understand the impact when deploying certain policies. Cisco has further reduced the impact to traffic during policy deployment, and for very few or odd use cases, please refer to the manual, right? So make sure that you operationally understand the impact of deploying policy, right? Or configuration changes or updates to your systems, right? Make sure you test in your lab environment or thoroughly read the guide, right? So the guide is your friend here. What we're going to do now is we'll go through an example of showing you how to look at some of those default settings, etc. So when we go into intrusions, let's go into edit here. This will take a second to show up. And we could have created new, and then it would ask us what configuration items that we wanted. So don't come in here and do this, right? Don't select all of them, right? Come in here and then say, block all, right? Or enable all. It's going to be a mess. Be very selective, right? You're going to use Firepower recommendations. It's going to do a good job. You're going to use Cisco Talos to give us updated on some of the signatures that need to be out for the latest vulnerabilities. But if we want to come in and edit a specific rule based on a specific use case, we can pivot to bug track, CVE, etc. to learn more about that specific rule and then enable it. So pretty easy, right? Malware policies. Okay, advanced settings. So leverage default settings unless the environment dictates otherwise. So there is an option to tweak, but again, tweak accordingly. When building malware policies, ensure that you optimize the policy. We talked about this earlier, right, with access control policy. So if you have a malware policy or file policy and it's for FTP, for example, be very specific. Take the direction of transfer in regards as well, whether it's upload or download or both, right? Make sure that you pick the correct file types of interest, right? Don't just grab everything. We want to optimize the platform and be effective with it, right? If you don't know, fair enough. But if you do understand, being more specific is better. What we'll also talk about real quick is a walkthrough of the archives. There's a bunch of zip files and what to do with those types of files, right? And how far the archive we can drill into. The alerting itself, we've already went through this in the previous section with access control policy around connection logging. So alerting is good. Make sure that you have it set up accordingly. All right, so let's get in this. We're going to go to malware and then the rule in question, and then we'll go to advanced. And you can see there's a couple things already default. So very high, that's the default from our outside looking in sandbox. We can inspect files, certain archives, and the depth of those, whether they're encrypted. So we can go down to 4 levels, right, by just making a configuration change here. For the most part, you're not going to touch very much here unless directed otherwise by someone like TAC, or you have a very specific use case. So once that's done and configured, you would have to come into access control policy and apply that. And I'm just showing you this here again, just to make sure that it hits home, right? Just because you have that file or malware policy doesn't mean anything until you apply it to an access control policy, save and deploy. The next thing that we're going to look at real quick here is some of the additional settings. Now, I talked about them briefly in the past section of this video, but I'm going to do it again here. So application protocol, be very selective here, right? And the direction of transfer. The action could be detect files, it could be block files, it could be malware cloud lookup, and block malware, right? If you have block malware, for example, you may want to do machine learning for executables, right? And obviously, if you have executables, we suggest that. Dynamic analysis, that's outside looking in sandboxing. Capacity handling, right? That's if for whatever reason we can't send it up for dynamic analysis at a specific time. For whatever reason, we're going to hold on to that file and do it later. Local malware analysis is high fidelity signatures. And then finally, you have the ability to reset the connection. SSL policies, we talked about it briefly, but when we are building TLS or SSL policies, you got to consider privacy, right? And that's a big challenge. So things like finance and health, we're going to exclude. When doing TLS decryption, consider leveraging corporate CA such as Microsoft. Ensure that the root CA is installed on the end station as a trusted root CA. This could be done using GPO or group policy deployment in Microsoft. And then things like identity policies, right? So if using passive authentication with Cisco Firepower User Agent, make sure that all domain servers are included. Only include groups and realms that are needed for policy enforcement. This will limit the number of users and groups that have to be downloaded and post-processed from Active Directory. The other thing is ICE, right? ICE baby, right? So instead of using Cisco Firepower User Agent, you can definitely use Identity Services Engine, whether you have a full-blown deployment of Identity Services Engine or you use Identity Services Engine's passive identity controller or ICE pick. Either one's an option, and it is the go-forward strategy at Cisco to help simplify user-to-IP mappings across multiple security platforms. So if we look at realms, since we've already talked about SSL earlier in this video, let's just go to realms, and I'll show you what I mean. So again, you got to go through the documentation or video that I have previously posted, figure out how to get the realm installed. Once it is in there, we then select when we're going to download, the time, etc. Here's where we're going to selectively pick the groups of interest, right? So we'll select the ones that we want. We may exclude certain groups here and take that approach as opposed to the include or a combination maybe. But the idea here is that in my case, it's sales, HR, and domain admins, and I'm done. Network analysis policies. Now, this one's important as well. So you should base your network analysis policy off of what you've defined in next-gen IPS. So if you use balance, connectivity, and security in next-gen IPS, then you should start with that same configuration with network analysis policy. So things like if you use inline normalization is enabled in your network access or analysis policy, make sure that GID 129 rules are enabled in IPS policy so that you're alerted when inline normalization is dropping traffic. Now, we'll talk about this, but again, the online help is your friend. It's going to tell you what items that you may want to turn on in other areas within the platform, right? It's going to tell you how to do. So let's go back to our network analysis policy. And I'm going to show you specifically the inline normalization as disabled here. And I enable it. I could then edit, right, from here. And you can see here's all the things that I'm going to look for, right? I want to normalize that traffic. And if I can't, or for whatever reason it's malformed, I then want to alert. I've now enabled it. The thing is that in order to get the alerting, I have to set up the IPS portion of it. So commit the changes. You can see that base policy just above the commit there. That's where I can set the balance, security, and connectivity to reflect what I've done in next-gen IPS, for example. All right, now I'm in intrusion, right? I did the pivot right into intrusion. I'm going to come in. I'm going to look at rules. I'm going to search for, in this case, GID 129. And I could then, from here, enable that to generate events, or maybe drop and generate events, right? And pretty easy. Once I do that, I go back into policy information. I commit the changes. And then ultimately, I've got to go and deploy that to an access control policy. If I want to learn more about a rule, for example, all I have to do is click it. It tells me a little bit about what the rule is for, shows me any rule summary, impact, detailed information, what effective systems, ease of attack, etc. Right? So fairly good in that sense of educating. There's that policy information, commit changes. It'll go and do its thing. And again, until I push that policy out, nothing happens. All right, so now we're moving towards things like device platform settings, NAT, flex config. So if we look at device management, it's pretty simple. The big one here, though, is platform policies. This ensures consistent deployment of devices. And I'm going to walk through an example of that, right? The idea here is that you may have 1 to hundreds of devices, and what you want to make sure is that the policy on the platform itself is consistent across the board, right? Like things like time synchronization, etc. So it's pretty easy. You come in, you can create a new policy. I've got one here already. You can see ARP inspection. I can add a banner. I got fragment settings, HTTP, ICMP, secure shell. Everybody here can read, right? So you can see there's a variety of settings here that I can set once. And once I have this configured, all I have to do then is go over to policy assignment, grab the actual devices that I want this policy deployed. And if this is regional or geographic, right, that you may want certain areas within certain countries based on certain laws, they may have different requirements, right? You can certainly do that and configure these differently for those devices. Now, the next thing I'm going to do, this is all bonus. This was not talked about in the guide, but the other one that you might want to do is create a health policy, right? So it's consistent, again, across all of the platforms. And then where it needs to be unique, you create a different policy for those unique use cases. So here I just quickly created one. I'm going to edit it, and you're going to see some of the things that are included, right? So AMP for endpoint status, AMP for firepower status, appliance heartbeat, and it goes on, right? Disk status, usage, HA status, interface status. All of that's good stuff, right? Enable the components that mean something to you, save that out, and then you'd have to actually go in and assign the devices, right? And that includes Firepower Management Center, right? So you can see All of them are here. I can hit apply and then deploy if I wanted to, right? I can uncheck one or two if I wanted to as well. And then finally, again, this is bonus. This was not included in the document itself, but rule updates. You want to make sure that you are scheduling those on off-peak time. Make sure that you understand what the policy deploy impact is to the environment. Likewise, you want to do that for geolocation. And you'll schedule that, and you'll save that out, and that'll allow it to go out and reoccur. And then finally, again, a bonus number 3 in this is add a task. You can do backups, regular backups. You can do an Nmap scan. In this case, we're going to go through and maybe run firepower recommendations, right? Maybe we do this weekly, monthly. You can also do this manually through change control, etc. Schedule it, give it a comment if you want to, and then apply. All right, so NAT, right? So do not overcomplicate NAT, right? Again, simple is always better. Unless extra NAT capabilities are required, you should use auto NAT whenever possible because it is simple to deploy, right? You only need manual NAT in certain scenarios when both the source and destination IP address in the NAT header need to be translated. For example, NAT exempt for site-to-site VPNs, right? We see that a lot. So let's go through and we'll do a quick example. You can very quickly come in and create new policy based on the device you have. I already have one here. And I've got 2 rules already set. So let's have a quick look at them and see how easy they are to build out. So you pick your source zone, destination zone, for example. I'm going to do auto NAT dynamic. So this is everyone going outside of the infrastructure from the inside network, NAT to the destination interface IP. So the outside zone IP. Then I have some advanced settings. For manual NAT, this one's static. So this one's actually going to be a web server that I'm publishing on the internet. So I've got the internal IP address of the web server. The protocol's HTTP. I've then got an object with the external IP address. And again, the translated source port is HTTP. So we're not doing any port translation here. Then I would assign my devices, just like I've done before, right? Save it out and then deploy. Pretty easy stuff. So finally, I'll talk a little bit about Flex Config. This is an advanced capability, folks. So to ensure proper usage of this feature, Flex Config should only be used by someone with advanced Cisco ASA technical knowledge. Typically, Flex Config is used when converting from ASA to FTD, or Firepower Threat Defense. And there are features required that are not directly supported within the management platform. So the management platform we've been using all this time is Firepower Management Center. If it's not supported, we've exposed Flex Config within the GUI so you can get into some underlying components. It is critical to only use supported Flex Config settings unless directly instructed by Cisco TAC. If you use blacklisted commands, you may run into support issues in the future. Remember, if you're not sure, ask, right? So all you have to do is come into objects. We've got a Flex Config container here with a bunch of pre-configured text objects. These text objects are used in the Flex Config object. So you can come in here and define that and then reference them in the Flex Config. So you can see there's a variety of pre-canned ones that are already created. Things in here that you might modify might be IP addressing, for example. And then you come in, and again, we've got a bunch of Flex Config objects already created. So you can come in and duplicate these and then tweak as required. The deployment type is every time. There's a couple of settings that you want to keep an eye on, right? So use the help object here. Once you've got it configured, if you want to deploy every time or only once, for example, or if you want to append or prepend, once you've got that set up, all you have to do is go into Devices, Flex Config, add a policy here, add the devices, and then select your objects. Fairly easy, right? But again, this is getting into some more of the traditional CLI type function within ASA. I can come in here once I add this object. Now, I have not done anything here, right? I've just added a default object here. But I can save this out. I can also go in and do online help if I'm not sure. Again, that is your friend. And then you can preview the configuration, right? I can come in here and pick the device itself, and I'll go and generate the config itself. It shows me what's prepended right at the beginning, and then anything that is appended at the end. In this case, there is nothing because I haven't changed anything in this case. But anyways, pretty easy stuff. So that's a quick summary of Cisco Firepower Threat Defense Common Practice Guide. It's supplementary to the documentation, obviously. It's just to help give you guidance. But here's some great references that you could use as well, right? So just pivot on these. It's going to bring you into other areas. And that's it, right? Cisco Firepower Threat Defense is a threat-focused next-generation platform.